My name is Ian Crawford. I'm a project manager with Digital Catapult, based here in Belfast. I've been working on a smart nano project for almost a year now. A very warm welcome to this FutureScope Smart Manufacturing Experiment briefing session. It's great to see such a busy room, to feel the energy of you all here today. Thank you for taking the time out of your busy schedules to be with us. It's a very, very exciting step for us today as we take a step together on a 5-year journey to develop smart manufacturing capabilities in Northern Ireland. It's going to be delivered by Digital Catapult as part of the Smart Nano NI Consortium. And you're going to hear more about Digital Catapult and the consortium very shortly. The next 5 years, this project will see up to 75 manufacturing companies take part in a series of initiatives to help them gain the necessary skills and knowledge to introduce the technologies, tools, and techniques of Industry 4.0 into the workplace. There's a lot of important detail to share with you and about our plans and how to get involved. So to that end, we've arranged an exciting afternoon of information, presentation, and demonstration. And so to business. First up, to give us an overview of Digital Catapult is Sue Maguire, our Business Engagement Manager here in Northern Ireland. Whilst Digital Catapult has been active in Northern Ireland for nearly 6 years, we appreciate that some of you may be unfamiliar to us. And Sue is here to tell our story. Please welcome Sue.
Welcome, and it's absolutely brilliant to see so many organisations represented here this afternoon. When I'm starting, I'm going to take us on a small trip down memory lane. And we're going to remember how Digital Catapult came to be where we are today. Digital Catapult Northern Ireland was launched in 2006 as a pilot project co-funded by the Department of Economy and Digital Catapult. Through the work of the DCNI team, Adrian Johnston, Nigel McAlpine, Adam Wallace, Brian Toll and myself, we were able to evidence the impact that having a digital catapult here in Northern Ireland delivered. At the end of the project, the decision was taken to continue with the centre in Northern Ireland and for the team to become full members of the Digital Catapult family. What that actually means now is that we, as Digital Catapult Northern Ireland, have full visibility of all of the programmes and all of the work that Digital Catapult UK actually do, which helps us to give more support to companies in Northern Ireland as they go on their tech innovation and digitisation journey. And as a reminder of Digital Catapult's function, role and what we actually do, I've got a short video.
Digital Catapult is the UK authority on advanced digital technology. Through collaboration and innovation, we accelerate industry adoption to drive growth and opportunity across the UK economy. We break down barriers, de-risk innovation, open up markets, and responsibly shape the products, services, and experiences of the future. Our focus is on supporting virtualization and cyber-physical systems, developing digital and resilient supply chains, and driving openness and interoperability of digital infrastructure. We create cross-technological collaborations and opportunities across future networks, immersive technologies, artificial intelligence, distributed systems. We bring together an innovation community of researchers, startups, scale-ups, and industry leaders to explore new ways of solving real-world challenges. Our goal is to accelerate new possibilities for every organisation we touch. We accelerate progress in the right way for the real world, responsibly, securely, and sustainably. Digital Catapult is part of the Catapult network that supports businesses in transforming great ideas into valuable products and services. Digital Catapult, accelerating the digital future.
So, as the video mentioned, Digital Catapult work with 4 core technologies. Future networks, that's including IoT and 5G. Immersive, including AR and VR, and we have the Immersive Lab in the Ormo Baths. Artificial intelligence, machine learning, distributed ledger technology, and most recently, quantum. But these technologies are the foundations that are building the future applications to provide an open and operable digital infrastructure, digital and resilient supply chains, and visualization and cyber-physical systems. Digital Catapult works with technology startups and businesses to help translate tech innovation into products and services that will transform key industries, increase productivity, and secure the UK's future global competitiveness. And we actually do this in 3 ways. By providing and supporting advanced digital technology consulting and experimentation. And I wanted to give an example of this that's actually based in Northern Ireland. This is some work that Digital Catapult did with NIAS and Ulster University and 3 industrial partners, Spirit, Thales and Denroy. And the project investigated the suitability of VR as a platform for training in the assembly and maintenance environments. Each individual partner put forward a use case, and the project delivered 3 demonstrators. The project also delivered evidence to support the deployment of virtual reality as a training tool in the factory environment. The second example I'd like to look at is the work that we're doing with 5G. Digital Catapult are partnering with the Department for Culture, Media and Sport in a £30 million project to help address the challenge for UK companies to engage with 5G technologies. The market is dominated by key players, Samsung, Nokia, Ericsson. But this Sonic Labs project is providing commercially neutral collaborative environment for testing interoperability and integration, which will help to build a UK ecosystem to support small and larger vendors to commercialise advanced wireless technologies and solutions. It's also worth noting here that a 5G testbed is part of the Smart Nano programme. A second way that DC helps to drive the adoption of emerging technologies is through the design and delivery of targeted innovation and acceleration programmes. And I wanted to talk about one specifically. Supply chains cover nearly every industry from life sciences, automotive, energy, utilities. And globalisation over the last 20 years has meant they've become increasingly critical to manufacturing businesses. They now account for 50 to 70% of manufacturing business costs and over 80% of CO2 emissions. The Made Smarter Digital Supply Chain Innovation Hub, that's quite a mouthful, I have to practice, I am counting on my fingers, is a £25 million project which is investigating how our supply chains can become more resilient. They're taking a collaborative approach to this innovation hub, which will support the development of technology solutions and provide further funding for specific supply chain innovation projects. It's worth noting here that we're currently looking for expressions of interest within this programme to deliver supply chain test beds. So if anybody would like some more information on that, please contact me afterwards. We're looking at funding made available of £315 £3,000. I'm smiling at Sinead because I said £3.50 last time. Okay, number 3. Finally, DC supports the deployment and scale of digital innovation so that the full impact of advanced digital technology can be realised by industrial end users and enablers. And I couldn't end a presentation on Digital Catapult Northern Ireland without mentioning potholes. This is some work that Digital Catapult Northern Ireland have been doing with the Department for Infrastructure Roads team. And this is effectively looking at how we address the challenge of potholes. More importantly, how do we repair them in the most efficient and cost-effective way? Originally, in 2019, when we started phase 1 of the project, 16 companies applied to take part. As we start phase 3, we are now down to 2 suppliers who are developing solutions using sensors installed on DFI fleet vehicles and TransLink buses. And that's really interesting because we're looking at the optimization of assets then. These vehicles are already on the roads, let's use them. Okay, so the sensors installed on these vehicles collect data on the road condition. That data is then interrogated by AI dashboards to basically identify the defects and predict the degradation of those defects. Okay, and I wanted to end by a quote that one of the companies who's been working on this since 2019 put forward. And I have to look at my pages because I can't see it. They say, Route Reports has tripled in size since the start of this SBRI project and has seen over £2.5 million worth of investment. The case studies, through customer case studies, SBRI has been pivotal to the success of Route Report products. And the reason I've included that one is if there's any reason to get involved in an innovation programme, then I think that text is evidence enough. Thank you very much.
Thank you very much, Sue. Thank you very much, Sue, for that little flavour of Digital Catapult. Of course, anyone around here with a yellow landlord this afternoon can give you a lot more detail. So, it is said that there is strength in numbers, and that's certainly the case with Digital Catapult's membership of the Smart Nano NI Consortium. Launched in 2021, Smart Nano NI is a unique collaboration of business and academic organisations aimed at driving self-sustaining industrial and economic growth through research and innovation. Here to tell us more about the Smart Nano NI project is Dr. Jason Wiggins.
Hello everybody, it's good to be able to present to you today. As said, my name is Dr. Jason Wiggins. I work for Queen's University, but I'm here to represent the whole of the Smart Nano NI Consortia. What is it? Is perhaps the most obvious question. It's a Northern Ireland-based consortium, as Ian has just mentioned, of 9 different organisations. It's industry-led by Seagate Technology, and it's funded by UKRI. It's part of the Strength in Places funding call. There are 2 projects funded in Northern Ireland, Smart Nano NI and our colleagues at the Artemis programme. Our project is for 5 years and it will run through until 2026. The project partners, who I'll present shortly, we're all working together, but really we want to have an outreach to as many people, organisations, companies in Northern Ireland as possible, and we're doing that through the programme organised by Digital Catapult, Future Scope, and we'll see what we can do to bring many people in to get the best possible impacts and outcomes. The technology areas that we're going to be looking at primarily are ones where Northern Ireland has particular strengths. The 3 that we've got listed there, medical research, data storage, and data analytics, I think are very appropriate. We have many, many great medical companies, ranging from the very large through to a whole range of new startups. Data storage. Seagate is one of the world leaders in data storage. It is an absolutely huge company, and yet very few people know how important their Northern Ireland operation is to their global business. It's a great partner to have on board. In fact, they're leading the project. Northern Ireland also has a great data capacity. We have a large number of homegrown companies, some of which are involved in the consortium. There's also been a huge work done by Invest Northern Ireland over the years to bring in foreign direct investment in companies operating in this area. We would really like to engage with as many of those as possible. Because what we want to do is engage with people in Northern Ireland and grow and expand economic activity and capacity. How will we do that? Well, quite simply, by encouraging and stimulating the growth of innovation. We want that to happen both within our project partners and in broader Northern Ireland companies. We're going to do this by putting in place facilities to help realise ideas and concepts through to real products, or at least prototypes. Our target is growth in high-tech manufacturing, especially in the areas of nanotechnology and photonics. So, who's in the consortium? There's a selection of all of the logos of the companies are up there, and this represents a grouping of companies both in Belfast and Derry, Londonderry. We have a mixture of companies, large and small, academic institutions, and all of us are working together to develop cooperation, collaboration, and co-developments. We want to work with you as well. Please engage with Digital Catapult and Future Scope programme to find a way into this. We're in the process of building facilities, and once they're built, they will be made available. As a quick starter summary slide, there are some logos of all the companies who are involved, and I'll briefly run through each of them in turn. So the first, Seagate, they're the project lead. As I said before, they are a world leader in data storage and hard disk drive technology, and they manufacture the recording heads for almost all of these devices here in the Northwest. They have extensive knowledge of high-tech manufacturing and possibly one of the most complex and technologically advanced fabs in the whole of the UK. Cerden, it's a leading provider of informatics and imaging solutions to enhance and speed up diagnosis in patients. It's based in Lisbon, but it has a worldwide impact. It focuses on the medical sector, especially the area of digital pathology. They're very interested in optics, image processing, and obtaining data and then processing that using whatever methods, AI or machine learning, are possible. The next company I'd like to present is Causeway Sensors. Now, Causeway Sensors is a QUB spin-out. Its tech is all based around nanophotonic sensors. What they're using them to do is to build devices that can be used to detect biological materials, biosensors, and they can be used in the biological and medical sectors. The next company is Yellow. This is a company based in Carrickfergus, and they design and manufacture automated test equipment and test engineering for a wide range of industries. But very specifically, they are one of the world leaders in laser burn-in. The world operates all its communications on optical fibers, which are driven by lasers. And Yellow make the test equipment that generates the initial burn-in process to make sure that those lasers are fit for purpose. Analytics Engines is also another successful QUV spin-out. It's based in Belfast, and its purpose is to provide data analytics solutions to help companies make decisions more effectively and efficiently from their data. What we were doing with Analytics Engines in the Smart Nano NI consortium is using their expertise and knowledge to help the partners gain insight and manage the vast amounts of data that each of the companies and partners can generate in what they're doing. The next partner is the Digital Catapult. I'm not going to say much more because there's a lot more presentations on this as we go. Moving on to the academic side, there are 3 academic partners. The first of these is the North West Regional College, which is based up in Derry, Londonderry. Fundamentally, there's no point in the companies developing these new great processes, products and devices if there are no people available with the right skills to help work. Northwest Regional College is introducing a training scheme, different programs, to help train up new staff in these Industry 4 technologies and approaches so that there will be people who can engage in the new business opportunities that will be created. With it being based very close to Seagate, there are some fantastic synergies there, and that will be that will be the site of the 5G testbed starting from next year. Ulster University is involved. I know there's a few people from Ulster here today. The focus from Ulster is on the McGee campus, and they're very much looking at robotics, AI, and machine learning. Queen's University is the next partner, and Queen's is using its knowledge and experience in data storage and photonics. Queen's will be the site of the shared facilities that are currently being built. So, what are the key activities of Smart Nano NI over the next few years? I've listed 4 up there. The first one is the Integrated Design Centre. We're looking at developing new ideas, new products, new technologies. These are all quite challenging, and it makes sense to do this in a virtual environment first, before you have to commit to the time, effort, and cost of actually creating something. So we are creating a virtual design centre using the latest software tools, and we're in the process of building that. In fact, it's nearly complete. Once that's fully operational, we'll be able to virtually simulate all of these new designs to check for their viability, the possibilities, and hopefully their performance. Following on from that, the next stage will be to build a prototyping facility. There's no point in us developing the virtual designs if we can't actually make them. So what we're doing at Queen's is we're getting a whole swathe of new equipment that goes beyond the usual research tools. These will be tools that will help us make devices, products, and prototypes that the partners can test their materials. And from next year onwards, once we have it all commissioned, we hope to make that available to people involved in the Future Scope programs. Strand number 3 is the Smart Photonics manufacturing site. This will predominantly be based on Seagate knowledge as they use their skill and expertise to scale up and make large volumes of these new products. And the 4th strand, that's why you're all here today. This is the accelerator program called Future Scope. I'd be happy to discuss any of these points or to give any more information about the type of equipment we hope to buy. Talk to me afterwards. Thank you very much.
Thank you very much, Jason. And that's a great segue into the next element of our presentation this afternoon. So you've heard about Digital Catapult, you've heard about the Smart Nano NI Consortium, and now we're going to find out more about the Future Scope Smart Manufacturing Experiment and how it could benefit your business and your clients and how you can get involved. So here to give us the details of the programme and how to be part of it, I turn to Brendan Lowry, co-innovation partner with Digital Catapult. Brendan.
Thank you, Ian. Hello, everyone. It's great to see you here in person today in Ormabas. I do recognise a lot of familiar faces. But before I get into showcasing what this programme really is, I want to just talk a bit about my background. I graduated mechanical engineering from Ulster University about 8 years ago, and I've kind of been in manufacturing ever since. I've done a stint in aerospace, medical devices, electronics, food and construction, and I've worked in roles across project management, MPI and engineering. But most recently, I founded a startup that developed a hardware and software platform in the horse racing industry. And what I learned in that startup is that innovation and technologies were key for really creating a better product for the consumer. And I learned that these innovation techniques and these deep technologies can be directly applied to manufacturing, truly create a transformable business. So does anyone know with a show of hands what smart manufacturing really is? A few, not too bad. Maybe we do need this program after all. I'll just show you with a brief explainer video what smart manufacturing really is.
From bottlenecks in supply chains to the pressure to decarbonise, UK manufacturers are facing a myriad of challenges. Businesses are constantly being told to innovate to remain successful, but what does this mean? Innovation is a process that helps businesses examine their operations, services, and products, and identify ways to improve them. Part of this process involves companies exploring the use of smart technologies to add value. A smart technology could be anything from robotics to reduce quality errors in the production line, to virtual reality for more efficient training and skill building. Take David, a manufacturer based in Belfast. His business has recently implemented an Internet of Things solution, which allows him to gather data from his equipment in real time to monitor their efficiency and condition. He's also getting advice on how machine learning could help him better predict shocks in his supply chain. And, with the help of a local 5G testbed, is trialling how a 5G connection could make these technologies even more powerful. See what smart technologies could do for your business today.
Thank you, Kieran. So that video gives a brief overview of what smart manufacturing is, but we are creating a program that really deep dive into smart manufacturing and how to support companies in that smart manufacturing journey. The program is called the Smart Manufacturing Experiment, and it is a 12-week series of accessible learning sessions which will enable participants to leverage facilitated and professional innovation practice and work with technology experts to identify challenges and opportunities within their business. And we will help them work towards the creation of a proposal for a prototype solution using smart manufacturing technologies. How will we do this? As I said, we will run a series of bespoke workshops, events, introductory seminars, tailored literature, lab visits, and sessions with technical experts in each field to really understand how to create a robust business case and a plan to implement smart manufacturing technologies for your business. These workshops and sessions are for companies of all sizes within manufacturing or manufacturing adjacent sectors such as the supply chain or design houses. We do welcome any team member from any department, but this programme works exceptionally well for decision makers within their organisation. People who, as part of their organisation, can introduce change, recognise problems or opportunities, and really get close to them. And these include engineers, R&D team, supply chain analysts, consultants, MPI, OPEX, designers, or lean transformation. What does a 12-week programme look like? It is an intensive programme for NI and UK businesses, as I said, to deep dive into smart tech, use cases and deployment criteria to drive long-term digital transformation. We use a professional innovation practice approach to work with companies, and we have subject matter experts in many technology areas such as nanotechnology, automation, photonics, AI, 5G, immersive tech, distributed systems, machine learning, and IoT. And we do this to stimulate innovation and R&D in the manufacturing sector. Companies who join our programme will reap a lot of benefits. First of all, in skills and training. It includes masterclass sessions, innovation workshops, including design thinking and challenge definition, demos and use cases of different technology, deep dives with expert technologists, and access to the resources such as the immersive lab that we have here in Normal Bass, and the 5G testbed that Sue and Jason mentioned earlier, and that comes online next year. Companies will get a better understanding of each technology and how it can benefit their business. The next benefit for companies is around that one-to-one sessions, spending personal time to work closely with technologists in each field to help define and solve problems and challenges within their industry. And this also gives the potential for companies to collaborate where necessary as well. And networking, becoming a member of DC Alumni and the Smart Nano Consortium opens up many opportunities for collaboration and communication to share problems, ideas and resources. So the 12-week programme that we're talking about is broken into a sprint approach. The first sprint focuses on getting to know the cohort, value stream mapping of the current state of the programme, and we'll begin to introduce the different technologies that are part of the programme. And in this case, it's nanotechnology and photonics with Killian. Sprint 2 is defining the challenge and mapping the ecosystem with introductions to more technology areas with those demos and use cases. And we'll even get some keynote speakers to join our programme as well and just give that valuable insight. Sprint 3 is around ideation and problem solving before moving into the deep dives and one-to-one sessions with technologists. We will also have some master classes on sustainability and supply chain because we know how important and closely linked these topics are with manufacturing. And finally, Sprint 4 is the demo day in which all the companies who are part of the cohort will present their learnings over the 12 weeks and then a roadmap to introduce a smart technology solution, and that will take place in early January next year. So over the 12 weeks, you will get to meet and work with a lot of different Digital Catapult staff. I want to quickly introduce the wider team who will be working on the project. So we have the innovation practice team that includes myself, Tom, Ash and Cara, who some of them are here today. And then we have the technology team. So we've got Nigel and Killian who are also here today. And then the remainder of the team are based in London. But they will be flying over and attending for the programme in person. So we just want to talk briefly about some manufacturing techniques. Firstly, immersive tech. Immersive technology can be described as new ways of creating, displaying and interacting with applications, content and experiences in a 3D environment which includes augmented and virtual reality. A key use case of immersive within manufacturing would be a design review. So typically a design review would be carried out with all parties from each department gathered around a table with a CAD design and a prototype. But imagine a company with many offices throughout the world. It's a lot more difficult to companies or to get colleagues together. These traditional design reviews can be transformed by using virtual and mixed reality. Team members can add comments, instructions directly onto the 3D model for immediate review, and then have that live manipulation by others who can join the meeting across many different devices remotely. And the benefit of these design reviews online, it really leads to a reduction of design cycle time and a reduction in product development costs. So such a big saving. Digital Catapult alumni company Fracture Reality have designed an enterprise immersive remote meeting platform to instantly meet colleagues and clients from around the world in real time using holographic meetings. Even providers such as SolidWorks and PTC have many ways to design, build and deploy XR solutions within their program currently. So even the suppliers and designers do recognise how truly powerful immersive can be. Local company Seagate, who Jason mentioned earlier, with support from Digital Catapult and I, were able to introduce a HoloLens to the facility. And Lester from Seagate will be showing us an exciting demo later on how that and their story of that product into place. Another smart manufacturing technique is IoT. IoT can be described as a network of physical objects that are embedded with sensors, software and other technologies for the purpose of connecting and exchanging data with other devices over the internet. Some use cases of IoT include data capture. So IoT devices can aggregate data from factory machinery and transmit it to the cloud for detailed analysis to produce those insights into the machine's parameters, such as setup time, idling time and stop time. And this data gives machine operators a detailed view of performance and notifies them of any potential issues. So for instance, if one machine is sitting idle too long while another one is too overutilised, to be able to balance that out and see that data is critical. Employees can also use IoT in manufacturing to quickly locate items in large warehouses. I have seen how valuable this is firsthand, especially in, again, a multi-site approach facility where a trolley of parts just magically disappears and no one knows where they've went to. You'd be surprised how often that happens. To combat this, you can equip items with RFID chips or Bluetooth tags. Another example of IoT within manufacturing is around that safety aspect. IoT sensors can track working conditions and detect hazardous material. For example, talk about gas sensors, if they can spot toxic fumes timely in a work and notify that manager who can evacuate employees from the site. This is very critical in manufacturing conditions, such as if they're very noisy, where they're cleaning or blasting equipment. IoT can also be used in predictive maintenance. We've all had our computer, our laptop, our phones crash, and we know how annoying that can be. But in manufacturing, it's a lot more significant, because that, it really damages machine downtime. And if machines are down, we're missing revenue. There's potential financial penalties there for missing deadlines. So the costs do add up. But IoT can spot how machines are operating by looking at different sensors, by looking at shock, vibration, and pressure. And it can compare that to historical data and use AI and machine learning to predict when a machine might fail. Again, a massive benefit for companies. And lastly, another benefit of IoT is around that visibility in the supply chain. Conventionally, managers, employees don't know that their items are damaged until they get to the customer, and that could happen in transit. IoT will be able to detect any damage or violation of storage in transit and trigger any condition adjustments, such as notifying the distributor. I have seen the effect of this again within a company that transports live animals. So, imagine where you're transporting a live animal where environment has to be very tightly controlled for animal protection purposes. So again, having this live data, this live feed is key for those. And the last tech area I want to talk about before I move on to the application process is around 5G. 5G is the 5th generation of cellular networks, and it is up to 100 times faster than 4G. And 5G is also ultra low latency and greater bandwidth. And in manufacturing, it promises a host of benefits, and you'll likely hear a lot more around 5G in manufacturing over the next while. From improving efficiencies to boosting output, harnessing this technology will prove truly transformational for the industry. For example, 5G-powered virtual reality could be used to connect an on-site engineer with a colleague working from home, allowing them to collaborate and work closely together without actually being physically close. This unique combination of smart technologies such as 5G, immersive and IoT will create something truly transformative for the industry. Vast amounts of data and information that will be taken from XR and IoT are being communicated in real time via a highly secure 5G network. Finda, they are a DC alumni company and they're based in London. They developed a solution to monitor and track assets in a live environment, such as moving parts throughout a factory or finished goods, both internally and externally to the factory. 5G for them meant that more data than ever can be captured, transferred, processed and distributed. They were able to significantly connect more devices to the network as well, which vastly improves our connectivity. This heightened visibility and efficiency and pace of production allowed by smart technologies are key drivers that contribute to having higher productivity levels in manufacturing. So the application process. For our companies who are looking to apply, the application process has 2 quick steps. Firstly, applicants must fill out and register using the FutureScope website, and I will share a QR code on a later slide, and actually some around the room as well. So once you sign up that QR code, it will send a link to Submittable, and Submittable is our application platform. And it will require you to just tell us a little about you and your company and your levels of understanding around smart technology, and to answer 3 short questions. Applications are now open for the programme, and the closing date is in the 13th of September at 5 p.m. There will be approximately about a week or so of judging and deliberation, so applications will be judged by a team of Digital Catapult representatives and will be scored to their questions on Submittable. And applications will be notified of their outcome on the 23rd of September, and then the programme starts on the 12th of October and run for, as I said, 12 consecutive weeks until January. The next steps really is to share with your team, your colleagues, your network. The applications are limited to only 15 spaces, so do reach out to me or the team today if you have any questions. Book another one-to-one with me, and yes, scan the QR code and get signed up. Thanks for listening, everyone, and I look forward to chatting to you later.
Thank you very much, Brendan, for all that detail on the programme. So we're going to change the gear a little bit here, and It's great to hear about these smart technologies in theory, but we're also going to have a look at what they can do in practice. And I'm delighted to welcome Lester Kelly from Seagate, who will demonstrate the HoloLens and tell us how digital Catapult first helped introduce the potential of this immersive technology into the Seagate innovation team. Lester.
Thank you, Ian, for the warm welcome. As we said, this is a live demo, so hopefully it does go right. Hopefully all the promises are fulfilled. As Ian says, I'm from Seagate Technology. We're based here in Derry, Londonderry. We are the largest head manufacturer for hard drives in the entire world. So there's nobody out there that produces as many heads as we do up in Derry, Londonderry. The team that I work with, Innovation, Automation and Control, I lead a small team of engineers there that basically look at Industry 4.0 technologies. People come to us with problems inside the group or inside the corporation, and we try and help solve them problems using technologies. And this is a mixture of technologies. We're looking at IoT with a 5G test bed. We're looking at implementing cobotics. We look at data analytics, workflow automation, data collection. And we also experiment with virtual reality, mixed reality, 3D additive manufacturing, anything with sort of Industry 4.0 technologies. We try and productionize it. So I'm here today to talk about XR technologies. What is XR? So XR is split into three categories. We've got virtual reality, augmented reality, and mixed reality. I'll try and explain the differences as best as I can. So virtual reality is fairly obvious. It's totally virtual. Somebody puts on the headset, they're totally immersed. They don't see anything in the real world. They can interact with any of the objects, and that world can be anything. Computer games, which is really the obvious scenario, but what it can also be is training scenarios as well. So you can train somebody in a very high-risk applications very safely because they're in a virtual world. The next two then, they're very, very similar. Okay, there's augmented reality and mixed reality. And this is basically where you overlay virtual objects in the real world. So the person utilizing this technology can still see the real world, can still interact with it, but they're virtually overlaying objects in that world that are developed by CAD design, so on and so forth. The difference between augmented and mixed reality is that with augmented reality, to interact with them objects, you have to use some kind of device, either a controller or you have to use a phone or a tablet. You have to press on the screen to move objects in the real world. Mixed reality is different. Mixed reality, you can actually reach out, pick up them objects and move them about in your hand as if they are real. So that's where the real difference comes in, so it does. Plus, mixed reality is spatially aware as well, more spatially aware. It actually uses time-of-flight sensors to detect all the objects in the environment. So, our journey. I love my toys, that's why I'm in this role, so it is. I love new technologies. Started exploring virtual reality and augmented reality. Back in 2017, maybe 2016, was over at an expo in Liverpool. I'd heard all about the HoloLens and I heard about the VR technologies, but anything I'd read online, how do we practically implement it in a manufacturing environment? So the first demo we seen was the HoloLens, seen it up and running. It was the first version of the HoloLens, got to play about with it and it was very impressive what they showed us, so it was. And I wanted to know a bit more about that. And then we started to look, there was a virtual reality booth there and I went up to it and I seen it and this person had created this virtual environment. It was training for facilities, switching on and off, replacing a pump. I was blown away. It was fantastic. You get really immersed in it. It was really realistic. But my concern was, right, well, how much does it cost to actually put that package together? How much time and how much effort has to go into it? And that's for one training scenario. But I got talking to the company and they says, oh no, we developed this in 5 days. And I was like, wow, great, fantastic. They're a company from Europe, Holland. So we wanted to get more information from them. So when I got back to the site, started communications with them. 5 days turned into 5 months. Okay, so it wasn't 5 days, it was 5 months to create one training application. Wasn't practical. Didn't give up there. I thought, right, well, we'll reach out. Seagate had like an expo sort of thing on in our local hotel. Lots of different companies from all over the UK came to it. And there was a VR company there as well came. Thought there was potential there as well, but again, sort of wildered away. That stage, to be honest with you, it was sort of, right, VR technology, AR technology is not there yet, we're not ready. But Digital Catapult came up and visited us, got talking to Nigel, so it did, and Nigel started talking to us about, well, you know, why didn't you look locally? Why didn't you look here right in your own doorstep? And I'd be ashamed I didn't. You know, I thought, right, if we want these big companies, want these great things, we have to go far afield. You know, they'll not be here in Northern Ireland. Nigel put me in contact with a company, Retinize, just down the road. And I thought, right, well, give them a try. I've nothing to lose. Got them on site and they blew me away, to be honest with you. Right here on their doorstep, they developed applications for us. And it was great from start to finish. They sat me down, I talked through them, look, this is what I want to try and achieve. And they says, yes, well, okay, we can do everything you want to do, but here are some of the hurdles that you have to overcome, and we can solve this by doing X, Y, and Z. They're a great company to work with. So, started to march forward, put together a couple of ideas of what we wanted to do, and we came up with two solutions. We wanted a fully virtual, submersive scenario, and we wanted sort of a 360 VR video. The problem we have in Seagate, the devices we make 100,000 devices on a 200mm wafer. So you can imagine how small they are. And the only reason that we're limited to 100,000 devices is because the electrical contact pads, the bit that actually does the reading and writing and all the smarts of the hard drive or the head is a lot smaller, so it is. And the problem we have is when we get vendors coming over to us or customers coming to us, it's very hard for us to portray to them, even our own people on site, it's very hard to portray to them the scale of the technology that we develop here in Northern Ireland. And we wanted to try and make that more visible to people. So sat down with Retinize, talked through a storyboard. The first day, what we eventually settled down on was you put on the virtual reality headset and you're in a room. You can see a picture of it here, so you can. And of course, we get our Seagate branding all over the place. You go over, you pick up the hard drive first of all, and you can look around it. You can see all the connectors, you can see your logos and branding and all the rest of it. And then you walk over to a microscope, put it into the microscope, and you look through the microscope, and you're actually shrunk down inside the hard drive. So that's the first bit. Now you're inside the hard drive, you're shrunk really small, and you can see all the components in it moving about, reading and writing information. And then the bit that we make is at the very end of an arm that reads and writes information off the disk. So you can walk over to it and you can pick it up. So it isn't, you can hold it in your hand, you know, and it looks very small. You put it into a microscope and you're shrunk down again. You know what happens, you're inside the head now, so you are. And that was great. That got, you know, you're shrunk down twice, you're shrunk so small, and it sounded really good. But then we were worried, you know, are they going to lose the concept of how small you've actually shrunk this time? So what we decided to do was have a red blood cell float past some of the components that we make. Our components that we make here in Northern Ireland are so small that they're actually smaller than a red blood cell. So they are. So you had a number of these floating past. And that was the first time that we got to convey to people, not just outside of Seagate, but even inside Seagate, how small our components are and how complex they are. So it was a good one-case scenario. The next thing then we done was a 360 video of our clean room, our manufacturing environment. People always come on site, they want into our clean room, but it's a clean room. We have to gown them up, we have to go through a pile of procedures, we have to wipe everything down, and it's not practical. We can't take everybody into the clean room. But we wanted to give them a feel of what the manufacturing process looked like, what our manufacturing tools looked like. So we developed this 360 video, and we split our processes down into 5 basic steps. And we repeat them steps multiple times, and we create the head. And we're able to do that through VR. And the thing to bear in mind is when we started these two projects, they were aimed towards visitors, customers, things like that, their vendors, to try and portray to them, you know, how small our components was. Actually turned out, see the people on site, the engineers that work developing this stuff day to day, they appreciated it nearly as much as anybody else, because it was the first time that they could actually see in 3D what the final component actually looked like. You can imagine 8-inch wafer, 100,000 components. It's not as if you can just look at it, and if you do look at it, it's 2D, you're looking straight down on it. So you are. Whereas this time they could actually get inside the head and see what it actually looked like when it was all constructed together and what all the different components do. The VR video inside the clean room, our operators inside the clean room 12 hours straight every day. What interest would they have in that? Actually, they loved it because they were able to get inside the tools virtually and see what the moving does, and we were able to explain to them this tool does X and that tool does Y, and this is why this is so important, and they all work together. So it was a really good success story, and now all the sites in Seagate have access to that content, so they do, and it's been shown at multiple shows. It was even over in the Las Vegas show in America, showing it to our customers worldwide there. So that was a great story. We explored the HoloLens, the first version of the HoloLens. I bought one, so it did, had it in work. And it did work, so it did. But it was the first version. There was a few bugs with it. The interaction with it, the only gesture you basically had was this pinch gesture to move objects. The concept was great. The theory was great, but just wasn't over that hurdle of making it practical in business. In 2020, everybody knows COVID hit. But just so happened to be in the end of 2019, Microsoft released their second version of the HoloLens, and I was really excited to get my hands on it. I was talking to Nigel constantly about it, so has he had one? Can I get my hands on it? Can I play with it? But they were really hard to get at that stage. It came to COVID, and thankfully Microsoft had resolved their manufacturing issues, and we were able to get our hands on it then. And I spun the idea to our senior management. We can't get people on site to fix our tools. We have semiconductor equipment. We try and ship people from all over the world to help us get these machines up and running. We can't get it. How are we going to solve this issue? Suggested the Microsoft HoloLens. Put on the HoloLens. The vendor on the other side of the world, within 5 minutes, can see exactly what the technician sees, right? Well, you can do that with a mobile phone. Well, the technician wearing the HoloLens is totally hands-free, right? So he can work away. The vendor on the other side of the world can see what the technician's doing. But on top of that, he can annotate on the screen as well. So while the technician is sitting looking at an electrical schematic board, the vendor can circle particular objects on the screen and say, that there's your fault. You need to try tripping that breaker, or try moving that breaker, or rewire this connection. And he can talk him through it live, so he can. And, with a HoloLens, because of the spatial awareness, the technician can be sitting here, he can walk away, walk around it, and because of spatial awareness, it actually leaves the annotation right where it is. So he can walk away from it and it'll still be there, he can walk up to it and it'll still be there. And that's where the real power of the HoloLens came in compared to all the other components or all the other devices we explored. On top of that, they can also share documentation. So if he wants to share a wiring diagram, if he wants to share PDFs, instruction manuals, he can do that live there and then, so he can. And at the same time, the operator or the technician can record footage as well. So 2020, we implemented the HoloLens for the first time here in Springtown. We were the first in Seagate to do it. And we pitched it to our IT group as well, because Seagate, we have a lot of policies to get through, we have a lot of security. And 6 months later, thankfully, we got it through the security process. And now we have 20 devices worldwide across 8 different sites, and they're utilised fairly heavily, so they are. That was great for remote support. Well, what's the next stage then? Can we use it for training? As I mentioned before, to try and develop a training scenario for each individual use case is very difficult. We have 600 manufacturing tools on site of 160 different varieties. Now, if you can try imagine training developing a virtual reality application for each one of them, that's a lot of, especially if they're going to take 5 to 6 months. Even if you can reuse some of the technology, still a long time to try and get the training across the board. With mixed reality and augmented reality, you don't have to recreate the whole environment. You only recreate the instructions to put stuff together. So it's a lot easier. It cuts down your development. So it does. But then the problem was, well, hold on, you still have to develop some kind of, software to make that all work together. Not with the Microsoft Guides application. It actually helps you to develop that. I'll talk a wee bit more about it in detail later, and I'll talk a wee bit more, I'll even be able to show you a demo. But what is the HoloLens? Can we give a bit more information about it? So it's a mixed reality headset from Microsoft. If you Google it online, you'll see loads of videos about it. It's got a basic Windows 10 operating system. It has time-of-flight sensors. That's how it uses a spatial awareness. So it knows where it is, where objects are, where flat surfaces are, where a chair is, things like that. It has, on average, about 2 to 3 hours of battery life. Now, it doesn't sound an awful lot great, but usually for most cases, it's more than adequate for what we need. But if you do need longer, you can just carry a battery pack around with you and have a cable plugging into the headset, and that can get you up to 6-8 hours. It has Wi-Fi 5 enabled on it, so it allows you to communicate with your network. It has eye tracking on it, so it can track where you're looking actually in the display. It has iris recognition, so it has for authentication. It has voice control. It has hand gesture control, which is what we generally use, so it is. So you really only have them 2 controls, voice control or hand gesture control. I tend to use a hand gesture control because I don't want people thinking I'm insane talking to myself all the time. So they tend to stick with the hand gesture control, and they get enough stick about that. So they're doing this all the time. But that's the way it goes. Environmental sound compensation for high noise areas. So you can appreciate We're on a manufacturing floor, there's a lot of noise from the machines, but the way the spatial audio is done with the HoloLens, it's very good, very clear, so it is. But it has Bluetooth capability as well, so if you're in a really noisy environment, you can put on a Bluetooth headset and link it to the HoloLens. It's all wireless as well. It's an open platform for development, and this is again was one of the key things we were looking at. Is it's great where we can pay all this money to Microsoft and get some of the applications right out of the box, but what if we want to develop something? With Microsoft, there is an open platform there that we can go and develop our own applications. They provide APKs so that we can go and develop that ourselves if we so desire. It is an 8 megapixel stills, 1080p videos. Mentioned spatial audio already. And then there's access control through PIN, password, iris recognition. Again, Seagate being very secure. We need to make sure that the device is secure, so we do. So Microsoft Guides, what we currently use it for. So this is the procedure for setting up a guide. First of all, you have to develop the framework of the guide on your own PC. That's key. You can develop on your own PC. It's very simple to do. It's like putting together a PowerPoint presentation. So you identify your task flow. What order are you performing your tasks in? You put in your instructions. You just type them in on as if it's PowerPoint presentation. And then you add your supporting material. So you can add pictures, you can add videos, you can add static objects, 3D objects, or you can add animated objects. So on some occasions when we want to demonstrate assembling stuff, we'll create the animated object and put it together. And then you have decision branches as well. So it's not just a linear flow from A to B. As we know, we encounter problems. We have to make decisions in the field. It allows you to do that branching and that decision making in the application as well. And then you print out a QR code, which links the guide to the HoloLens, so it does. What you do then is you go into your manufacturing floor, you locate your QR code. Later on you can come up and see, but it's just basically a simple small QR code. And then you get the HoloLens to scan that QR code, and that loads up the guide. For the first time, the engineer that developed the guide loads it up in author mode, and he then starts locating all the objects. So you put together the task flow. They now need located in the actual manufacturing environment. Remember, this isn't a 2D screen, it's 3D. You can actually locate these guides wherever you want all over the place, so you can. So you can have stuff sitting on a table, you can have stuff sitting on the floor, you can have stuff virtually inside a machine, and you can have bulletin boards. So you can on as many bulletin boards as you want. So you anchor your instructions and you anchor your supporting material, whether it be diagrams, animations, whatever, and then you deploy it. Let the operators have a go with it. So it is. So why did we do this? So we have additional operators every year. Seagate, we're an employee of 1,400 to 1,500 people on site. We have operators every year, and we continuously hire new people, so we do. But we have to train them people. We're working on semiconductor equipment. If they break some of our material accidentally, it's a lot of money for Seagate, so it is. So we want to make sure we train them. So we want to try and make that process a lot easier. Multi-skilling operators and additional tool sets. So when operators comes in, they're trained initially on 1 or 2 tool sets. But we want to expand their knowledge as they progress through Seagate. We want to give them the ability to learn new tools, learn new processes. So another avenue we do for multi-skilling operators. New tool sets being installed continually, requiring additional training. So we install, as you know, semiconductor continuously grows. We continuously install new types of tools, and we have to create new training packages for that as well. But we have to get the operators up to speed with that. With this, we can do that fairly quickly. Comprehensive and standardizing training across all operators. So when they use the HoloLens, every operator gets the same content. He's not relying on the trainers on different shifts teaching the same thing. Okay, and there's nothing left out. It's a sequence of events that they have to go through and that they all get the same information, so they do. And you can provide as much information as you want. You can point out warning signs, you can talk them through the process, the correct process of doing things, what to look out for, things like that there. And then we can review training material at operators' own pace. So, you know, what you find is, at the moment, we take an operator into the room, we train them on a tool, and we'll maybe spend half an hour with them. That's great, okay, but for a new operator, that's a lot of information to take in the very first time, so it is. So, you know, he maybe wants to go over and get a refresh of that. He can do that with the HoloLens. We still may do the initial 5-10 minutes introduction to the tool via a live person, but then that operator can go and grab that headset and go through it at his own pace, at his own comfort. So it makes him more comfortable, but at the same time making him more efficient and ensuring that he does the task correctly, so it is. So now I'm going to attempt to do a demo. And fingers crossed this works. we know what it's like with technology. Never goes right, but we'll try it. So the headset might just take a wee second to load up here. As you can see here, I'm just pressing buttons in mid-air here. I'm putting in my PIN code. That's good, I think we're good now, so we are. Okay, so you can see what I'm seeing. You can see this menu. When I start up the headset, this menu pops up, right? And it follows me around. Wherever I move, it'll move there, so it will. If I want to get rid of the menu, it's all hand gestures. So I just hold up the palm of my hand. You'll see in my wrist here something loaded up, so I can either click it, or I can simply do that, and it'll load back up again if I need be. So we wanted to try and simplify this process as much as possible for operators. We don't want them having to learn, right, well, how do they operate the HoloLens headset? So we didn't want them having to go in, open up the menu, open up a particular application, load the particular training scenario they needed. We want to make that as simple as possible. And thankfully, Microsoft have done that well. We basically, as I mentioned before, we print out the QR code. So I just kneel down, look at the QR code, and the button pops up. Press the button, and it says application link. Okay, so here I can dismiss it or open it. So in this case, I'll open it. You see a couple of balls floating about the air. Everybody smile, you're all on big screen now. I'm always very impatient, so I'm always wondering, is this working right? Restart it, restart it. It is, thankfully it is. So just bear with us. We are, usually the HoloLens only has to do one item. So it is, whereas this, I'm trying to stream it to laptop and then getting it onto the screen as well. So here it's wanting me, would you like to open this in an operator? Yes. Okay. And now it's asking me anchoring. So all these objects that I'm going to be working with today are all anchored to this QR code. So that's how the HoloLens knows X, Y, and Z coordinate locations for all the elements that it's got. So yes, it's anchored right. I can see the green box in around the QR code. And I'll just confirm that. And now it starts loading up these environments. Here's an example of Microsoft Provide. You can see these mountains. If you look very carefully, these clouds are actually moving. And there's a wee car driving down the road, so there is as well. If you look over to the right-hand side, we've placed an earth in here with a ball out round it. That's all nice stuff, nice features of what it can do. That's not really practical for Seagate. We don't need clouds or mountains, so we need to create our own content sometimes. We've added in our own Seagate logo here to make sure you know we're all Seagate. So here is a demo of one of our hard drives. And I can just walk around this. You can see that this hard drive stays still. And then the animation starts to open up. I can start looking at the different components inside the hard drive. So I can, trying to recognize all the things that we do. So we do. And you can see here then, we get a couple of information popping up as well. And you can make this animation do whatever you want, so you can. You see here is a head gimbal assembly, what we call the head gimbal assembly, the arms basically moving back and forward across the platters. The bit that we make in Seagate Springtown is at the very, very, very end of that wee needle that does the reading and writing information. And there'll be one head on arm, both top and bottom, so it will read both sides of the platter. So enough of hard drives. Here, what's the practicality of this? So I want to instruct an operator to do a task. So here we have 3 blocks that I want to try and put together. It's a wee puzzle. Some of you have probably seen this before. And please come up later on. Challenge you to do it without the HoloLens, and then you can try and do it with the HoloLens. So here, James Thompson, one of the engineers that I work with, he set up this here that I can pick up any box in any order, so I can. So I'll just reach out and pick this one up. As soon as I pick it up, it's recognized that my hand has went into that area, and I started playing this animation, saying, right, the next scenario was to pick up this bit, and I put these together. Oh, then pick up this bit, rotate it round, slide it down, and slab it together. Voila, done. So it is. Now I have to try and remember how to take it apart later. So, let's went through that and go on to the next task. And it's asking us a simple question here. What was Meta Platforms formerly known as? Well, obviously Facebook. So I'll just grab the number 1 and that's it. Going on to the next step, so it is. So that's the end of that. I can also select, this is the type of screen that will pop up with the instructions you can see in front of you. And it'll instruct the operators through whatever they need to do, so it will. So we can just exit out of that. And then, are you sure you want to exit this guide? Yes, I'm very sure. And I'll close this back down again. At the home screen. That's it. So it is. So that's a demo done. Thankfully that went very smoothly, so it is. So, whew. And if anybody, this will be available here afterwards. Please come up, talk to me. We'll take you through it, try it. We'll wipe it down to make sure everybody can have a go on it if they want to. And if you do want more information on it, reach out to me at Seagate. We're always here to talk. That's one of the good things about the consortium, is that we are here to work with other companies as well. We're manufacturing, we might be in a very different sector, but we can all learn from each other. We've all the same challenges, just different challenges, but they're all the same. So, all right, thanks.
Thank you very much, Lester. We trust you found this demonstration and our presentations this afternoon interesting and exciting, and that they've given you food for thought with regard to potential application of smart technologies for your own business and those of your clients. A big thank you to our funder, the UKRI Strength in Places Fund, whose support is enabling this project to happen. We also thank our fellow Smart NI Consortium members, our speakers, and of course the wonderful Digital Catapult team here today. And it remains for me to say thank you again for coming along today. Do enjoy the rest of your afternoon with us, and let's make manufacturing smart. Thank you.